For example 1 part B, we're asked to find the equation of the tangent line to the graph of the function f of x is equal to 2x plus 1 over 3x plus 1 at x equals 1. So what I'm going to do is I'm just going to graph out roughly what that function looks like, because I can. This isn't that hard to do. This is a rational function. So what do we know about it? We know that it has a vertical asymptote when the denominator is equal to 0, specifically because nothing in the numerator cancels with anything in the denominator, otherwise we'd have a hole. So we're going to have one when 3x plus 1 is equal to 0, or when, if you solve this guy, you get x is equal to negative 1/3. So right in here is a vertical asymptote. It's got a horizontal asymptote at 2/3. Okay, that's the limit. If you take the limit of this function, as you go to infinity or negative infinity, you get 2/3 out. So it's going to have one up here at a height of 2/3, like that. And of course, if you plug in a number that's on this side over here, like even if we plug in 0, we get 1 over 1, which is higher than 2/3. So we've got some. We know our functions up top here. Now I'm not going to test to see whether it crosses this horizontal. Remember that they can, but it's really not even worth it at this point. And then I know over here we're going to have negative values. Okay, so let's take a look here. If I plug in, let's say -1. Actually, let's check that. If I were to plug in, let's say a negative here, I don't know, let's say a -10, then my numerator would be negative, and so would my denominator. They'd both be negative. However, even though they're both negative, they still are probably down in this section. So without testing points or anything, I'm guessing it looks something like that. And we can always go ahead and check with a computer program. Let's say we go ahead and we grab like Desmos or something like that. I should probably bring that up on my screen here so that I've got it for these videos. I have to give our computer a second here. It's just a little bit slow. Okay, hang on. I'm going to pause it so that you don't have to wait and watch this. Okay, so here's what our graph looks like. All right, and that's exactly what I had sketched out. Now what we want to do, if I zoom in, we want to know what is the slope of the tangent line going through right here. Okay, let me get up a little bit more. Right through here. It looks like it's going to be negative. Okay, so what we're going to do, we want to know more than just the slope. We want to know what the whole tangent line equation is. So we do need to calculate the slope. Okay, so we can go ahead and we can use the formula, but again, I think it's nice to be able to draw what's going on here. So I need at 1, I've got a point. Oops, close enough. And there's a tangent line that goes through it. So the slope of the tangent line is given by the derivative at that point. So I'm going to take 1 and plug it into here. So let me get a general derivative out, and then I'll evaluate it at 1. So when I do that, to take the derivative of this, that's going to be, now I'm mixing up my notations here, but that's fine. I mean, there's really nothing wrong with that. So 2x plus 1 over 3x plus 1, like that. So the derivative of this, I'm going to use the quotient rule. So it's the bottom times the derivative of the top, because the derivative of the top is just 2, minus the top times the derivative of the bottom over the bottom squared. Again, if you want to use numerator and denominator for your words, so it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Okay. So let's just go ahead and simplify this a little bit. This is going to be 6x plus 2 minus 6x minus 3 over 3x plus 1 squared. So the x's on the numerator are going to cancel out because we have 6 of each of them. And so I've got 2 minus 3, which is negative 1, over 3x plus 1 squared. That's f prime of x. So f prime at 1 is going to be equal to negative 1 over 3 times 1 plus 1 squared, which is negative 1 over 4 squared, which is negative 1 over 16. So what that tells me is the slope of this line, the m value of that line, is negative 1 over 16. Now notice again, we thought it was going down, and it looks like it's verified here with this. Okay, at least I got a negative value. I didn't get a positive value out. So it's an easy way to check. But that's not all I need. We need to find the equation of the line. So I'm going to erase this, because we don't need that anymore. And if you need it, just go back and rewind the video. Okay, let's get rid of all this up here. So I've got the following. I've got y minus y1 is equal to m times x minus x1, right? This is the point slope form. Okay. Now what is my y1 and my x1? Well, I need my actual point on the graph. Well, this is 1, comma. Now if I plug in 1 here, I get 2 plus 1, which is 3, over 4. So it's going to be 3/4. That's the point on the line. Okay, now let's go ahead and plug that in here. So I'm going to get y minus y1 is 3/4 is equal to m times x minus, now my x1 value is 1. So this will be y minus 3/4 is equal to negative 1/16 x plus 1 over 16. So y will be equal to negative 1 over 16x plus 1 over 16 plus 3/4. We'll get a common denominator here. Okay, so this right here is the equation of the tangent line, the green line. Now another way to do it, and I'll check these in just a minute, but another way to do it is to go ahead and use the formula that's given to us. So the formula says that the equation of the tangent line, now this formula is given on page 90, the tangent line is equal to the function evaluated at the point plus the derivative of the function evaluated at the point times x minus x naught, where x naught is equal to this guy right here. So y is equal to f at 1 plus f prime at 1 times x minus 1. Now x and the y are the variables here, so let's go ahead and compute this. Well, f at 1, we already know f at 1 is 3/4. Just take 1, plug it into here, and you'll get that to be 3/4. Plus f prime at 1, you still have to go through and find the derivative of this, okay, and evaluate it. So we already know that we get negative 1 over 16 times x minus 1. If you notice, this right here corresponds with this right here. And so it's going to reduce to give us the same value. Now let's go ahead and check it with both Wolfram Alpha and Desmos. Okay. So again, the reason I'm showing you this is so that if you're working on the problems, if you want to do some of the even ones, you can check out, you can do them and you can check out to see if your answer is correct or not. So what do we have for our original equation? Well, that already is given to us in this red line. I'm going to make it a little bit darker here, actually. Okay, so there's our red line, and our equation is, for our tangent line, is negative 1/16 times x plus 13/16. And what I want you to notice is that at 1/3, our blue line and our red line intersect and we've got our tangent line. We can also check it with Wolfram Alpha, so we'll ask it to find the tangent line of the function 2x plus 1 divided by 3x plus 1 at x equals 1. And so again, it'll go through and it'll do the computation for you. Here, it shows us what the graph looks like. Okay, and it gives us our equation, which is exactly what we had.